Everybody, my name is Dave Gordon. I'm from Nationwide Children's Hospital in Columbus, Ohio in the US, and I am excited to introduce our project, our phenotyping project, PheBee. All right, this is a review for most of you, but a phenotype is simply any observable trait of an individual. In a hospital, why does this matter to us? Well, in our research, they're useful for forming cohorts of similar subjects. They can help us give detailed characterization of individuals. And then on the hospital side, they helped us to provide prompt and appropriate personalized care. However, and I suspect we're not the only ones in a hospital, phenotype data is stored in many different systems, not really well characterized, not structured, and definitely not connected to each other. So this prompted our new project. We had some key goals for PheBee. We want to leverage existing ontology standards. There's no reason for us to reinvent a wheel that so many people have spent so many years doing. We wanted to harmonize both manually curated and automatically extracted links to terms. We want to model clinical patient interactions in a way that can give us very much specificity to how we're associating terms with patients. We want to extract phenotype terms and, importantly, modifiers from unstructured clinical text. After all, a patient has seizures, a patient doesn't have seizures, or maybe a patient's mother has seizures, are very different concepts and we need to treat them as such. We want to explicitly capture the provenance for all terms we're associating back to, say, a clinical note or a manual assertion. We need to easily substitute new extraction technologies. This is a fast-moving field. We don't want to tie ourselves to one technology when tomorrow there might be a new one everybody's using. We wanted to implement the phenopacket standard from GA4GH for both import and export of data so that we could interact with other open systems. And we wanted to allow both that systems interaction as well as allowing power users to directly query the graph underlying the data. To better fit in with our hospital infrastructure, we've chosen an AWS stack for this. Don't panic if you don't use it. Nothing here is tied to it. We're using AWS Neptune as our graph database. And then we've got various serverless technologies for upstream and downstream interaction. All right, so let's take a closer look here at how we're asserting a link between a patient and an ontology term. Each hexagon here would be a node in our graph, and each green line an edge. On the left, you can see one of our patients, and on the right, we can see an ontology term, say maybe an HPO term. Next to the patient, you can see a clinical note that we've pulled from their electronic health record. And rather than just saying, okay, this node is connected to this term, we add one more node in the middle there, a term link. This allows us to take in only not the term, but any modifiers alongside it. And then we can add one or more pieces of evidence that explain why are we linking this term to this patient. If we take one step back, you can see two patients here, each with their own clinical data. We link each to the same ontology term, and they have their own evidence as to why each of those links is made. And then if we continue to zoom out, you can see this graph database taking shape. In the middle here, you can see an ontological hierarchy, say maybe HPO or Mondo. On the right, you can see one subject that has a clinical note that has linked them to multiple terms, and this helps us to give that detail to that subject. And overall, you can see how we could form a cohort of similar subjects through this graph database. You can see them linked to different levels in HPO, but that we could form a cohort of all the similar terms there. All right, let's talk a little bit about our extraction pipeline here. To begin, in our system, we're getting a feed of notes into our clinical data lake. From there, we can define one or more extractors. Each of those will query the terms for an appropriate batch of notes. We'll run the extractor. We'll run context extractors for each term to say whether there's any modifiers that need to be applied. And finally, we'll use Neptune's bulk import to efficiently load them into our system. We will have a talk on Thursday about how we're working with context there. Go see it. A couple quick translational use cases in our hospital we're using PheBee for. First is called NeoGX. This is for our level 4 NICU patients, which if you're not familiar, are some of the sickest kids in the hospital. We're using the phenotypes from PheBee as features into a machine learning pipeline that will predict whether they would undergo genomic sequencing. This helps us to provide quicker and appropriate care to those patients and get them out of the NICU as fast, get them an answer as fast as we can. For Cavalry, this is a genomic variant process where we're trying to prioritize variants that should receive more manual attention from our variant scientists. There's way too many for them to evaluate everyone individually, so this helps us to prioritize those and apply our time well. Again, if you're interested in the medical side, we'll have a talk in about an hour about that one in Transmed. All right, and finally, I want to thank both my team, our internal collaborators, BIML, and the Institute for Genomic Medicine at Nationwide Children's, and really importantly, all the people in this room and elsewhere who have put together these ontologies and standards. We wouldn't be able to do this and help our patients without all of you. So thank you, and thanks for everybody for being here.